So hello, and we will be discussing module number 5, which is about arbitrary unions and intersections. Okay. So first, we discuss finite unions and intersections. Okay, so most of the laws of the set theory that we have examined up to now involve one, two, or three sets. For example, the commutative laws involve two sets and the associative laws involve three sets. So, uh, next na i-discuss natin na part is paano kapag yung mga unions and yung intersections natin is dumadami na sila. Okay? Pero, titingnan muna natin yung finite na case. So, pag finite, so for example, sa union, pwede tayong magkaroon hanggang up to n sets. Okay, so we have a sub 1, union a sub 2, union, and so on up to union of a sub n. And similarly, sa intersection, we have a sub 1 intersection a sub 2 up to a sub n. So, ano ibig sabihin nun? So, sa union, if meron tayong union na ganito, if x is in the union of the sets, it means na x is in a sub I for some I. So, ibig sabihin nun, si x ay nandun siya sa at least 1 doon sa mga sets na given. Okay? So, if and only if siya, so mag-work din yung pabaliktad. So, sa intersection naman, x is in the intersection if and only if x is in a sub I for all I. Ibig sabihin, sa intersection, nandun siya sa lahat ng sets. Okay? So, tingnan natin yung example. So, yung first example natin is the distributive laws. Okay? So, prove the distributive laws for finitely many sets. So, yung first is A union B sub 1 intersection B sub 2 up to B sub n. This is equal to A union B sub 1 intersection A union B sub 2 up to A union B sub n. So, ganun din sa number 2, nabaliktad lang. Okay? So, proof. Doon sa number 1, so yung proof natin is by mathematical induction. So, first is basis step. So, what if n equals 1? If n equals 1, isa lang yung set natin, B sub 1 lang. So, si A union B sub 1 is siya na rin lang yun. So, this is true. So, for induction step, we will assume na meron tayong up to B sub k. So, assume that A union B sub 1 up to intersection ng B sub k is equal to A union B sub 1 intersection A union B sub 2 up to A union B sub k. So, ang need to show natin is yung B sub k plus 1 is also 2. Okay? So, from the assumption, so yung A union B sub 1 up to intersection B sub k plus 1 is equal to this. So, i-group natin from B sub 1 up to B sub k. Okay? So, using distributive laws, si union, magdi-distribute siya dito. Okay? So, group na to. So, we have A union B sub 1 intersection B sub 2 up to intersection B sub k. Then, intersection A union B sub k plus 1. So, using yung induction hypothesis natin, itong first part ay equal dito sa nakadistribute yung mga union. So we have this A union B sub 1 intersection A union B sub 2 to A union B sub K intersection A union B sub K plus 1, which is yung need to show natin. So therefore, na-prove na natin yung number 1. So yung number 2 is left as an exercise. Similar lang din yung proof niya. Okay? So next is generalized unions and intersections. Okay, so let tau be equal to the set A, B, C, D, where A, B, C, and D are sets. Okay? So yung tau natin is a collection of sets. So set siya na may lamang mga set. Okay? So previously, sinabi natin na X is a member of A union B union C union D if and only if X is a member of at least one dun sa apat na to. So in other words, if X is an element of some member of tau. Okay? So pwede natin siyang isulat as X is in A union B union C union D if and only if for some y in tau, X is in Y. So X, yung X ay nandun sa set for some set na nandun sa collection of sets natin. So sa example na to, since yung tau natin ay finite, kasi we have finite sets, pwede nating isulat yung union. Kung ano yung mga union ng members ng tau. However, kapag infinite siya, hindi natin malilis lahat ng members. So yung case na to, susulat natin yung notation na to. So this will represent a arbitrary collection of sets. So union of tau. So gawin natin yung definition. Let tau be an arbitrary collection of sets. The generalized union of tau is denoted by union of tau, so malaking union is equal to the set of all x such that for some y in tau, x is in y. So, nasabi na natin ito kanina. Okay. And another one is for generalized intersection. So, this one is generalized union. Yung susunod naman is generalized intersection. So, si intersection naman, instead na for some, for all na siya. Ibig sabihin, for yung X ay element siya nung generalized intersection if X is an element of every member of tau. Ibig sabihin, lahat ng mga sets na nandun sa tau, nandun si X. Yung generalized union, basta nag-exist lang siya dun sa kahit isa. Okay? So, example. So, let's find the generalized union and generalized intersection. So, yung number 1, yung tau natin is the set containing the sets 0, 1, set 0, 1, 2, and 0, 1, 3. So, yung generalized union is lahat lang ng elements ng mga nasa set. So, pagsasama-samahin lang natin yung mga elements ng kada set. So, here we have 0, 1, 2, 3. So, 0, 1, 2, 3, lahat ng mga elements nila. And yung generalized intersection, titingnan lang natin kung ano yung common sa lahat ng sets. So, since lahat sila may 0 and 1, pasok yung 0 and 1 dun sa generalized intersection. Pero since si 2 ay nandun lang siya sa isang set, wala siya dun sa ibang set, hindi siya kasama dun sa generalized intersection. So yung generalized intersection natin is 0, 1. Okay? So for number 2, we have tau is equal to the set of A sub n where n is an integer and n is between 1 and 39, where a sub n is equal to 0, n minus 1, and n. So first, kailangan muna nating alamin kung anong itsura ni a sub n. Okay. So, si a sub n, so for example, we have a sub, so yung n dapat natin na integer between 1 and 39 kasama si 1. So for example, we have a sub 1. Ano itsura ni a sub 1? So according sa given, yung a sub n natin is 0, n minus 1, and n. So si a sub 1, we have 0, we have n minus 1, which is 1 minus 1 is 0, and n, which is 1. So si a sub 1, ang naman niya si 0, 1. Okay? Next, we have a sub 2. Si a sub 2, anong laman ni a sub 2? So we have 0, n minus 1 is 2 minus 1, which is 1, and 2. Si a sub 3, we have 0, we have n minus 1, so 2, and n, 0, 2, 3. Si a sub 4, we have 0, we have 0, 3, and 4, up to 39. So si a sub 39, will be 0, 38, and 39. Okay. So yan yung laman ng mga sets natin. Okay? So yan yung itsura ng mga a sub n natin. So first, so this must be generalized union. So yung union, generalized union natin is lahat lang ng mga elements dito. So makikita natin dun sa sets natin, we have from 0, we have 0, 1, 2, 3, 4, and so on hanggang pi 39. So yung generalized union, so dapat ito ay union. So dapat ito ay union. So union, generalized union is from 0 to 39. Okay? And yung intersection, generalized intersection natin is 0. Set containing 0. Kasi, si 0 lang yung common dun sa lahat ng sets natin. Okay? So, since tau can be a finite collection of sets, the generalized union and generalized intersections are generalizations of the intersection and union of a finite collection of sets. Okay? So in other words, kapag meron tayong finite collection of sets, then yung generalized union nila is yung union lang ng sets. And yung generalized intersection is yung intersection lang ng sets. Okay? And so example 3, prove that every element of omega is a subset of the generalized union of omega. Okay. So, para ma-prove natin na yung every element is a subset of uh, generalized union. So, gagamit tayo ng pick a point method. Okay? So, kailangan nating i-prove na yung A is a subset of the union of omega for all A. So, yung A natin ay isang set. Kasi yung laman ng omega is a finite collection of sets. Okay? So, similar sa tau. So, assume that A is in omega and let X be in A. Okay? So, meron tayong set at meron siyang element doon. Then, X is in B for some B in omega. Okay? So, that is B equals A. So, hence, yung X is in the union. Okay? So, paano nangyari yun? So, nag-start tayo sa isang set at meron tayong maglalat tayo na may element doon sa set na yun. Okay? So, kapag tinignan natin yung set natin, so kapag meron pa tayong ibang set doon sa omega, let's say B. Okay? Then, since if we let na B equals A, then yung X natin is nandun din siya doon sa B. Okay? So, ibig sabihin nun, yung X is nandun siya sa generalized union kasi part siya nung nandun siya sa loob ng isang set na nandun sa omega. Okay? Since yung definition natin ng generalized union is X is an element of the generalized union basta nag-exist siya dun sa at least isang set natin. Okay? So, ang ibig sabihin nito, yung every element of omega is a subset ng union. Ibig sabihin, pag titingnan natin yung union ng isang ng omega or ng finite collection of sets, yung mga elements doon, subset siya nito. So, for example, kung titingnan natin yung kanina, so for example, meron tayong 0. 0 is a subset of the generalized union. So, si 1 is a subset din siya dito. So, every element dito is a subset. Okay? So, yun yung sinasabi doon sa proof natin. Okay? So, one of the most important applications of the generalized intersection and union of sets is to sets of real numbers. Before that, we give a definition. This is called the epsilon property for real numbers. So, given any positive real number epsilon, there exists a positive integer m such that 1 over m is less than epsilon. So, gagamitin natin yung definition later. So, recall lang natin yung standard notation for intervals. So, pag meron tayong mga intervals, so ganito yung mga definitions niya. So, nakasulat lang siya sa set notation. Okay. So let's proceed to example 4. Let omega be equal to the set, of all closed intervals from 0 up to 1 over n, where n is 1, 2, 3, up to infinity. So first find the generalized union, and next find the generalized intersection. So first, ang una lagi natin gagawin is alamin natin kung ano itsura yung ng laman ng mga sets natin. Okay? Or this case, ano itsura ng mga intervals? Ano itsura yung at nung itsura ng mga laman ni omega. So here, yung omega natin, meron tayong set of intervals. Okay? So yung omega natin, so if n equals 1, ito ay 1. So, mali ata yung nailagay ko dito. Dapat ata open interval to. So, ayusin natin. So, this should be an open interval. Tapos ito ay yan. So, note that ganito yung itsura ng sets natin. So, if n equals 1, ito ay 1. If n equals 2, we have from 0 to 1 half. And if n equals 3, we have 0 to 1/3 and so on. So, first, we need the generalized union. So, by observation, makita natin na yung generalized union natin is this must be 0. So, ito dapat ay interval. So, yan. So, we show that yung generalized union natin is yung half open interval from 0 to 1. Okay? So, ano natin gagawin yun? So, let x be in the generalized union. Then, by definition, x is in y for some y in omega. Okay? So, itong first part na definition lang. So, by the definition of omega, ano itsura nung mga y? So, yung itsura ng mga y natin is half open intervals from 0 to 1 over n for some n equals 1, 2, 3, and so on. So, definition lang. Now, nakikita natin na si 0, yung half open interval from 0 to 1 over n is a subset ng 0, 0, 1 na half open interval. So, therefore, si x, since nandito siya sa y, nandito siya, and ito ay subset nun, therefore, si x nandito din siya. Okay? So, na-prove na natin yung conjecture natin na 0, 1. Okay? So, for the other inclusion, since equality pala siya, so, papakita pala dapat natin na dalawang sides. So, first, let x be in union of omega. Show that x is in 0, 1. Yung next, let x be in 0, 1. Show that x is in the union of omega. The next part, let x be in 0, 1. Since si 0, 1 is nasa omega, x is in y for some y in omega. So that is y equals 0, 1. So hence, x is in omega. So parang binaliktad lang natin yung ginawa natin dun sa okay. Next, the intersection. So by observation, nakita natin na yung intersection ni omega is si 0 lang. So bakit? Kasi pag titingnan natin yung set, since infinite siya, palapit siya ng palapit kay 0. Eventually, si 0 lang yung magiging common sa lahat ng intervals natin. So, yun yung conjecture natin. So, to-prove natin siya. So, again, titingnan natin yung two sides. So, first, note that 0 is in the intersection since 0 is in nandun siya sa interval natin sa omega. So, automatic siyang nandun kasi ito ay close kay 0, meaning kasama si 0 sa lahat ng intervals. So, ang kailangan lang natin i-prove na if A is not equal to 0, then A is not in the intersection. Okay? So, clearly, si A, kapag negative siya, wala siya kay intersection. So, assume natin na A is greater than 0. So, by the epsilon property, there is a positive integer m such that 1 over m is less than A. Ibig sabihin nun, kung mas malaki si A kaya 1 over m, then si A wala siya doon sa interval from 0 to 1 over m. Kasi nga, mas malaki siya doon. So, A is not an element of every member. So, not an element of every member, therefore, wala siya doon sa intersection. Therefore, it follows that 0 is the only element of the intersection. Okay? So, in the following, we will use sets of the form omega equal to D union A such that A is in tau. So, paggamit natin to, X is in omega means that X is in, X equals D union A for some A in tau. So, X, kapag X is in the union, means X is in D union A for some A in tau. At kapag yung X is nasa intersection, X is in D union A for all A in tau. So, prove natin yung generalized distributive law. Okay? So, kanina, sa unang part, prove natin yung distributive law for finite collection of sets. So, dito naman, generalized na siya. So, prove natin siya two sides. Okay? So, first, let X be dito. So, D union intersection omega. So, let X be here. So, need to show nandito siya. So, first case, since union to, assume that X is in B. Then, for every A in omega, so by definition, for every A in omega, X is in B union A. Okay? Therefore, si X ay nandun sa intersection. Okay? Kasi lahat, ah, kasi si D, automatic siyang andun siya lagi. Okay? So, for example, yung mga sets natin, we have, sabihin natin yung intersection natin is, sabihin natin A, tapos B. So, kahit ano pa yung set na nandito, yung X ay member siya ng D union A. Kasi nga si D laging nandun. Therefore, member siya ng intersection. Case 2, assume that nandito siya sa intersection ni omega. Then, X is in A for every A. Okay? So, definition ng intersection. So, therefore, si X ay nasa D intersection A for every A. Therefore, X is in the generalized intersection. So, in each case, totoo siya. Next, pabaliktad naman, let X be in the generalized intersection of D union A. And cases ulit to. So, first case, assume that X is in D. Therefore, nandito siya sa D union intersection omega. So, obvious siya. Next is, assume that X is not in D. So, paano pag wala siya sa D? So, by assumption, X is in, kasi dito siya, X is in D union A for all A in omega. Therefore, kung wala siya doon sa D, nasaan siya? Andun siya sa A. Okay? For all A in omega. Pero this shows na X is in the intersection. And hence, nandun siya sa D union intersection of omega. Okay? So, yun na yung proof ng generalized distributive law. Okay. Last example, prove following. Generalized union of tau union omega is equal to the generalized union of tau union the generalized union of omega. So again, double set inclusion. So first, papakita natin na ito ay subset nun. Next ay ito ay subset ng kabila. So yung first muna, let X be in the union of generalized union of T union omega. Then, by definition, X is in A for some A in the union in tau union omega. Okay? Case 1. So either nandun siya sa tau or nandun siya sa omega. So case 1, kapag nasa tau ka, therefore, nandun ka sa union of tau. Case 2, kapag nandun ka sa omega, nandun ka sa union ni omega. So either case, nandun siya sa union nung dalawa. Okay? Next, we start here. So let X be in here, union of tau, union with union of omega. So case 1, assume na nasa union of tau ka. So by definition, X is in A for some A in tau. Case 2, pag nasa union of omega ka, then X is in A for some A in tau. So either case, X is in A for some A in tau union omega. So pag pinagsama natin yung dalawang cases na yun, ganito siya. Hence, si X is nandun sa generalized union ni tau and omega. Okay. So that ends our discussion on arbitrary unions and intersections. So dito sa exercise niyo, same lang din yung gagawin mo dun sa mga una. Sundan nyo lang yung mga examples. Take note dun sa mga corrections natin kanina. So kung meron kayong questions about sa discussion about sa exercises, message na lang ako. Okay. So that's all. Thank you.